So hi everybody. Thanks for having me today. I'm excited to get a chance to talk about something I've been talking about quite a bit recently, which is my dissertation work. But it's exciting for me to have such a broad and varied expertise audience here. So really, I'm going to kind of give what really is an overview. You'll get a sense for how much data we have from these couple studies. So one thing I'm looking to do as kind of going forward is to kind of expand on what we have here, looking for ideas, both from the data we have and kind of ways to move this forward. So I'm going to talk here about a few studies that we've run at the University of Illinois. Technology issues. Excuse me too if you see any kind of Illinois symbols pop up. I'm slowly transitioning over Iowa stuff. But a couple studies here, kind of the overarching goal of which are to kind of examine the efficacy of videophone conversations in mitigating some of the distraction that we see from cell phone conversations during driving. So I'll talk about kind of initial study we did to kind of look at that effect, and I'll define better what I mean by videophones. And then I'll talk about some work we did to kind of flesh out those effects a little bit more, looking at whether we see age differences there, as well as differences in the effectiveness of these kind of interventions in different situations. Feel free to stop me too if I'm unclear about anything, or if you have questions. I'm happy to answer. So really what I'll be talking about here kind of gets back to this issue of driver distraction, which I think everyone here is at least somewhat familiar with, the idea that doing something else while you drive is probably not a good thing. We know that, specifically what I'll be talking about are cell phone conversations, so the act of conversing while you're driving. So there's a variety of other things you can do which are probably worse to be doing while you're driving. We know that talking on a cell phone changes the way that you drive. People who are talking respond slower to unexpected events. We also see changes in where drivers are looking when they're distracted. And I'm not going to get too theoretical here, but from a very kind of basic sense of what we know about attention, these distraction effects are really being driven by limitations in our attentional system. So if we think of attention as kind of this pool of resources that we have to spread around to various tasks that we're performing, if we're doing just one thing, we have enough resources to go around. We can allocate this attention to the task of driving pretty well. But the reason we get costs when we try to divide our attention is because we have a limited pool to divide amongst those things. So that's all pretty straightforward, and I don't think probably surprising to anybody. What's a little bit more surprising, given those kind of given what we know kind of about basic attention, is the fact that not all conversations seem to be equally disruptive to driving performance. And what I mean by that is that we tend to see less distraction resulting from passenger conversations than for cell phone conversations. I'll kind of keep referring to this point throughout the talk today. When I'm talking about passenger conversations, I'm talking about kind of best case scenario passenger conversations, so passengers who are engaged. And I'll get back to that in a minute. So we know that there's this difference between cell phone conversations and passenger conversations. A few different groups have done research on this. This is some work from Dave Strayer and Frank Drews at the University of Utah, who've done a lot on driver distraction. And what they're doing here is comparing cell phone conversations, so a driver who's talking on a hands-free headset to someone who's sitting outside of the room, versus a driver who's got someone in the car with them, so someone sitting next to them in the simulator. And we can look at driving performance, and we see these differences based on the type of conversation that the pairs are having. So here the task was to take a specific exit to get off the highway. And what we see is that drivers who are talking to someone on a cell phone are missing that exit much more often than people who are talking to a passenger. One thing that's important to note here is that you still see drivers who are talking with passengers who are missing that exit, so we're not completely eliminating that effective distraction, but we're reducing it relative to cell phone conversations. Okay.
So
yes.
can they I would assume, so the passenger is some kind of confederate of the experimenter?
The passenger here is just another participant, another subject.
Yeah, because it'd be good to like blindfold them so that they're not stopping their conversation when they know something tricky is coming up with the driving situation.
So that's a really good point.
Oh, sorry.
That's a good point, and Dave has actually done this in a recent paper. So if you don't allow this conversation partner to talk about whatever they want, you don't allow them to talk freely, you make them tell a story that's conscripted, you lose this effect.
Okay. So that makes
and that's very, very important.
Yes, if they're not talking to anybody, do they get all of the?
They don't. You don't lose all of it. They still get a few, but it's reduced compared to this. So it's down in this region. Okay. So what really seems to be driving this is kind of what Jody alluded to, I think. No, it's a good transition. Is really that there's differences in situational awareness, what we call situational awareness, kind of awareness of what's going on in the task, and at any given time, what's likely to happen in that task. And there's differences because passengers can see what's happening in the driving scene and they can see the driver. We can get at changes in situational awareness by looking at changes in the conversation that the pairs are having, particularly kind of how the partner's talking to the driver. And we see a number of different things which suggest that the conversation partner is more aware when they're the passenger. This is, I don't have the citation, but this is the continued work from Dave Strayer when they look at the content of those conversations. So we see more references to the traffic scene, what psycholinguists might refer to as kind of grounding, talking about common things in the scene. We also see changes in the complexity of the conversation. So passengers in the car are generally talking less to the driver, especially when the traffic starts to get heavy, when the driver looks really engaged in the task. And really what that probably serves to do is reduce the workload that the driver is experiencing. And then finally, that conversation partner, that passenger, can help alert drivers. So if you think about that navigation task, one of the reasons that drivers with passengers are missing that exit less is because that passenger is helping to point out, oh, there's Springfield Avenue, we're supposed to get off here. So I mentioned that I'm going to be talking about kind of the best case scenario, and this again gets back to kind of that point. If we have passengers who aren't engaged in the task, we lose that effect, and this is particularly prevalent among novice drivers and kind of teenage passengers. So we lose that benefit of having a passenger in the car when our passenger is distracted, when they're not helping the driver kind of focus their attention on the driving task. Okay, so we kind of started here kind of as our inspiration, but what we what prompted this whole conversation was we had one of our colleagues who was driving to a conference down in Florida, and he talked about for about 2 hours, he said he was using FaceTime talking to his brother while he was driving. So probably a really terrible idea. You probably don't want to be looking at your phone FaceTiming, but this kind of prompted this discussion of how we might be able to improve situational awareness for someone who's not actually in the task with the driver. And I think this kind of comes back to this idea of telepresence. I think that's a good term. I think it's kind of the idea why things like teleconferencing and video calls, why we tend to like these things. And it's because they kind of give us more context about the situation. So here's I think this is from the 40s, a very old sort of videophone. But now, obviously, we have new sorts of technologies where we can kind of visualize more information than just hearing someone's voice. So this is kind of our inspiration for all the stuff I'll be talking about. But really what we wanted to ask was whether providing remote conversation partners with this additional video information could help reduce some of this distraction by increasing situational awareness. So making partners more aware of what's happening in the driving scene, whether that changes the way that they're going to talk to drivers even when they're not in the car. And the idea here is really pretty simple. So if you imagine that we have a conversation between a driver and a remote partner, so someone talking to them on their cell phone, the idea is simply that you could take your smartphone and just kind of set it up on the dashboard, and you could use that to kind of relay information to your friend who's not in the car with you, who's talking to you. So this could be video of your face, video of what's happening out in the driving scene. And we wanted to see if providing this extra visual information was enough to increase situational awareness. So if only seeing kind of a small amount of what you'd see as a passenger could boost your situational awareness when you're not in the car. And then whether that translated into changes in driving performance, similar to what we see when we look at passengers compared to cell phone conversations. Okay, so I mentioned that we have 2 studies which I'll talk about here. This first study was just kind of a proof of concept. Does this work? Do we get changes in the way people talk? And does that affect driving behavior? Here we had 24 pairs of young adults. Both pairs were, so these pairs came in together. They were friends who came into our lab. When they came in, we assigned one to be the driver, one to be the conversation partner, and then we had them drive along these busy highway scenarios in our driving simulator. So you can see our simulator here, a fixed-based, kind of full cab with a 360-degree view, so these screens wrap all the way around. What I thought was a pretty high-fidelity simulator, I won't refer to it as high-fidelity anymore after being at NADS. This is the interior of our cab here. You can see that we've got some eye tracking set up on the dashboard. I won't talk about that here. It's pretty noisy data so far. So this is what our task looked like. It's pretty bright, right? Can you guys see it? You'd be able to get an idea. So really what we wanted to do was to see how well people could respond to unexpected events as a factor of the sort of conversation they're having. So you can see we have 2 types of events. These merge events, you can imagine someone kind of cutting you off in traffic. Imagine driving into a big, busy city. And then we have these braking events where that car in front of you is going to slam on its brakes and stop suddenly. Okay. So there were roughly 12 of these events. For this first study, these events were based on distance. So when that car gets a certain distance in front of you, he's going to cut in front every once in a while. There's some drawbacks to that, which I'll get to in a minute. Okay, so I mentioned that we had 4 drives, which led to 4 different conversation conditions, which are diagrammed here. So our drive alone condition, just a baseline condition without conversation. Our passenger condition, someone in the car with the driver. Cell phone, just like Dave Strayer set up, we've got someone in a separate room talking via hands-free headset. But our really important and kind of novel condition is this videophone condition. And here we're showing our conversation partner, again, who's in a different room, video of the front channel of our simulator. So we're just relaying that straight to one screen in this other room. And then video, we've got a camera pointed right at the driver's face. So they can see the driver's face and they can see what the driver's seeing straight in front of them. One thing that's important to note here is that what the driver sees isn't changing in any of these conditions. Really all we're changing is what the passenger has access to. So when these pairs came in, we asked them, we wanted to create these naturalistic conversations. We thought that was important, that these pairs kind of be conversing, be able to change their conversation as they saw fit. So what we asked the pairs to do is we had one of them start telling a story about a trip they'd taken during each of these drives. We found that the pairs would start talking about the stories for a little bit, and then the conversations became very, very natural. We were really worried that pairs were just, maybe one person was going to tell a story the whole time, or the pairs would just stop talking, but the conversations looked very much like you would have, or undergrads would have with their friends in their car while they're driving. And I'll show some examples of what those conversations look like. In terms of analyzing those conversations, what we did was we had an independent rater, and this is a separate rater for each study. And what we had them do was we had them go through and code when the driver and the conversation partner started and stopped talking. So anytime they started or stopped, we had them code that, as well as the initiation of any references to traffic. And by references to traffic, we coded only references to the immediate traffic scenes. So this has to be something that's happening in the driving task. It can't be, I got in an accident last week. You can see some of the transcribed traffic references just from one pair down there. Obviously, people felt pretty comfortable in the car. We also coded where that conversation partner looked, so we wanted to get an idea of kind of where they were looking most of the time to get that important information, and whether that changed, whether they were a passenger or in the videophone condition. I'll get back to that at the end as a way, kind of maybe an extension, kind of looking at what information is most important for the effects I'm about to show. So we first wanted to see if providing this additional videophone information just to the conversation partner was enough to reduce distraction. And importantly, I'm going to say reduce distraction. What I mean is reduce distraction relative to cell phones. What you'll see here is that in most cases, we're not eliminating distraction completely. So what we have here is the likelihood of collisions happening during our events. So like I said, we had roughly 12 events occur during each drive. About half of those were merge events, half were break events. Because we set things based on distance, as I mentioned at the beginning, it made it hard to look at changes, or to look at response time across events. So we got pretty drastic differences in response time from event to event. So what we ended up looking at here was just the likelihood that a collision happens, so the cars kind of intersecting with each other. So what this value is here is the likelihood of a collision given that an event occurred. So a value of 0.06 here, for instance, means that there was a collision on 6% of the events that happened. All right. What you can see here, this is collision likelihood for the merging events in each of our 4 conditions. You can see that we're getting a nice reduction in the likelihood of collisions for both our passenger condition and our videophone condition relative to our cell phone condition. These are also within subject's error bars if anybody is interested. This effect kind of disappears with our braking events. So again, these are lead vehicles braking in front of us. You can see these are much noisier generally, and we don't see any difference between our 4 different conditions here. So most of the benefit seems to be happening for these events which are occurring in driver's visual periphery. Okay, so we get some differences in driving performance. We then wanted to see if those differences were in fact being driven by changes in how situationally aware the conversation partner was. So to do that, we coded these traffic references. So we wanted to look at partner situational awareness by looking at the number of references the partner made to traffic. So this is the average number of traffic references started by the conversation partner. What we can see is that we're getting a lot of references to traffic in our passenger condition, but also significantly more traffic references in our videophone condition relative to our cell phone condition. So some evidence for videophone partners being more aware of what's going on in the situation. We can also look at the complexity of traffic, the complexity of conversation to see if passengers and videophone partners, because they're more aware of what's happening, tend to just talk less and make fewer references. So this is the average length of utterances that the conversation partner made. And you can see that the length of the duration of utterances, is reduced for both our passenger and videophone condition compared to our cell phone condition. And what this likely serves to do for drivers talking less and making shorter utterances, partners talking less, is it likely reduces the workload that the driver's experiencing from the conversations. Okay, and that's kind of where we left off for study 1. So we see these changes in driving performance. Our first driving experiment, while fairly naturalistic, was not very well controlled. So one of the things we wanted to do was to get at response time, which I'll get back to in a second with the second study. But we also wanted to kind of expand those results, see if those results translated into both other groups of drivers and to different driving situations. So we really asked 2 questions here with this second study. The first was whether videophones might enhance situational awareness for older conversation partners. So older adults here defined as 65 to 80. There's reasons that we might expect that older conversation partners can't make use of that videophone information, particularly that older adults typically experience deficits, kind declines in cognitive abilities, which are likely important to being able to monitor two channels of information. So things like the ability to switch between those two channels or divide their attention. However, I think there was also reason going into this to expect that older adults may be able to benefit from these video phones, namely that we know that experience can offset some of these kind of general basic cognitive declines here. Secondly, so in addition to looking at those age effects, we also wanted to see whether these video phone effects translated into differences in other driving tasks, and we chose to look at intersection driving behavior because it really allowed us to answer the question of how much visual information is really necessary to engender this benefit, to engender this increase in situational awareness. So if you think about this, passengers are able to see most of the driving scene, or most of at least what the driver is seeing, but our video phone condition, this is a little cut off, only shows a limited portion, so we're only showing the front channel here. And what this looks like, you saw kind of what it looks like in the highway situation. You can see most of what's happening in front of you. In our intersection scenario, however, which I'll talk about in detail in a moment, when someone stopped at an intersection, the really important stuff is happening kind of pretty far out to the left and to the right, cars approaching and passing, and you're not getting any of that information with the video phone. So if it's really critical to see the important portions of the driving scene, we might lose some of the video phone benefit here. Okay, so we also boosted our sample size here, so we had 38 pairs of younger adults, 38 pairs of older folks. This required us to do a lot of screening, so anyone who's worked with simulators is probably pretty familiar with simulator sickness. And we kind of combined the two worst situations of having old folks and having a lot of turns and intersections in a fixed-base simulator. These numbers should be flipped here. We screened at about a 50% attrition rate for our older folks coming through. Our conditions here look the same, so again, the same within subject's design. Again, two tasks here, same simulator. I'm going to talk about each of the driving tasks and then the results for that task, just to kind of keep things organized a bit. So for this highway task, we shortened our drives just because we wanted to be able to fit that intersection scenario in at the back end of things. Relatively the same number of events, but the important change that we made here was instead of fixing things just on the distance, we set our events this time based on the time to contact, so the distance divided by the speed. And what that allowed us to do, as I'll show in a minute here, is to look much more precisely at changes in response time to see if that's what's driving the changes that we saw in collision rates. But other than that, the task here looks very much the same. Okay, so here we have first driving performance. So we again wanted to see whether driving performance changes as a result of these conversation conditions. So here we have brake response time in seconds for both our younger and older folks. You can see here that there is a cost in general to conversing in any of the conditions relative to relative to driving alone. So we're not completely alleviating the benefit, but what we are seeing again here is a nice reduction in response time for both the passenger and video phone conditions relative to the cell phone condition. Importantly here, that's true both for younger and for older drivers. So older folks are benefiting pretty much to the same extent that our younger drivers are. So that was response time for our merging events. This is response time for our lead vehicle braking events. These results look pretty similar to what we saw in the first study. They look a little cleaner because we're looking at response time. But in general, we don't see any difference between our different conversation conditions. So we see a little bit of a cost relative when we compare our drive alone condition and our cell phone condition, but not much of a benefit or no benefit here for passenger or video phone. So again, the benefit seems to be occurring during those merging events. Just like the last experiment, we wanted to see whether this was being driven by changes in situational awareness. So again, this is the number of, or the average number of partner-initiated references to traffic. We can see for young folks, we're getting this nice increase in our video phone condition, again, compared to our cell phone condition. For older adults, though this effect is in the correct direction, the expected direction, we don't see that effect pulling through as significant. So a little bit less evidence that older adults are making more references to traffic. We do see changes in kind of the overall complexity of conversations, just like we saw in experiment 1. So again, this is the average duration of utterances that conversation partners are making, and you can see that there's this nice drop in the duration of utterances, suggesting that pairs are talking less and making shorter utterances when they do decide to speak. Okay, so I think it's helpful to kind of see a few of these and what they look like. And I think it's pretty apparent, having watched a lot of these videos, of some of the differences in the way these pairs are talking. So this is a pair in our cell phone condition. So our conversation partner here is sitting in a separate room. She can't see anything what's happening with the driver here. This is the front channel of the driving simulator, what the driver's seeing. Okay. And the sound's going to come out of that speaker in the middle. It's going to be a little quiet.
He is a technician. He served in the military 20 years, graduated, and went back to school and became a tech. And my daughter Christy is a biochemist, which did study for her master's here at the U of I. And my daughter...
So you can see a braking event occur there. The important thing to notice is that she doesn't stop talking at all. She just keeps talking the whole time. This is very common. So she doesn't know what's happening. She can maybe hear the brake once he starts to brake, but by that time it's probably too late to change anything. And you can contrast this with the video phone condition, which looks very much like the passenger condition. So in this case, she can see, she's looking at those two screens, which are kind of where you guys are. When she's looking to her right, your left, she's looking at his face, so she's looking at the screen with this image. When she's looking to her left, your right, she can see the driving scene. Okay.
I want to go up in.
Yeah, Seattle's a neat city, but I didn't get to spend that much time there. But I was in the park that's very near it.
Have you been to glaciers?
No.
If you haven't, you need to go, because on the United States side, the ice is not as heavy as it once was.
So here you can see, unlike the cell phone condition, first off, what you can notice is that she's kind of talking to him. So she'll look at the screen when she's talking to him, but kind of keep checking back to see what's happening in the driving scene. This is very common of what we saw. You can also see, and probably most importantly, that once the event starts happening, she just stops talking for a minute, kind of waits for the event to be over before resuming conversing with the driver.
I want to go up in.
Okay, so that was our highway task. So we see benefits, some benefits for both younger and older folks in response time, particularly when the event happens outside of the driver's visual periphery. And that seems to be driven by changes in situational awareness on the part of the conversation partner. I'm going to talk very briefly here about this intersection task, which we added on. It's a very simple task. Pretty much all drivers are doing is just following the direction of a lead vehicle through an intersection. So this car is going to pull up and turn left. Drivers are instructed just do the same thing you saw that car do. Okay. We had 6 of these, which doesn't seem like very many, but it was a struggle to get people through even 6 intersections. Okay, so first off, whether I want to look at whether the conversation changed driving performance. And we do see some changes in driving performance as a product of conversation conditions. So here This is the time drivers waited at the intersection before turning, so the time from coming to a stop before they initiated the turn. We like to think of this as kind of an index of decision making. So the idea here is that if drivers are sitting at the intersection for longer periods of time, they're having a harder time making decisions about when it's safe to go. And this is collapsed over age. And we can see here is that wait time is reduced for the passenger and videophone condition compared to the cell phone condition. Most importantly, I think we do see some changes in situational awareness compared to the cell phone condition. So again, this is the average number of references initiated by our conversation partner. We can see pretty large, well, not necessarily large, but significant changes in the number of traffic references for both the passenger condition, but most importantly for the videophone condition here. So
References per what?
References, this is the total number of references per condition.
So this is after over 3 references over a whole trial.
Over 6, so they're making one every other, on average every other.
Okay.
Yep. So still, it's not a huge number of references. These are pretty short too. And we're only looking in that period. I guess I can show you
So,
what these
John, I mean,
Yeah.
were the passenger references, because they could see the sides, I mean, was the content of those different?
No, it wasn't, not really. They weren't talking about the cars very much. They were talking about things that they might have seen. So I'll show an example here of what these look like. So a lot of times what they would talk about is a car that had maybe just passed, things like that. So really, it's not necessarily that they're pointing things out. It's more that they're just kind of generally talking about the driver. So this, I'm going to show a few examples here, just like I did for the highway task. So again, this is the cell phone condition.
Your road, you take that hard right on the curve.
Yeah, that's right.
And then
You can't
go-
see what's
it's
happening.
It's called Deer Hollow. It's actually off of Slade Drive. It's a brand new street.
Oh,
And oh my gosh, the deer is, there's always at least 15 deer walking around.
really?
He's got a little pond behind him and a little wood.
It's going to
which
jump
sends
here. It's
the
just going to
Southmore
move to
basketball
another
coach.
intersection.
Oh,
He teaches here at Leo School in Urbana.
oh, really?
So we still have connections to Muhammad. Lots of friends still there. Like I say, we just love it.
Yeah, I like them.
Well, from where we live, people in that area get to town
So you
for
can
the
see
weekend. A lot
a
of
car going through,
stuff out
something
of
that people would
Prospect.
point out after the driver
Where do you
turned.
live
So that's the cell phone condition. Muhammad's a town outside of Champaign.
The road, you take that
Deer are
hard
obviously
right on the
an
curve.
issue in
Yeah.
Champaign.
By joining with
So this is the
third
video
party
phone
users.
again. When he's looking to his left, he's looking at the driving scene. Right, he's looking at her face.
Was our 10-year friend?
Probably 5. We had a 5 and then a 10. And
Yeah, they had a 5, but this was the 10-year question. They had it with another high school because the same thing happened in Rockford where a new high school was built. And so they had it, it was interesting, they had a huge conference center and it's a huge ballroom and they put the doors across between, for the first part, you know, where they have the banquet and the, I don't know, they give awards for the finest and stuff for children and all that. And then for the second part,
by joining with
So we can see there is, I don't think it's as apparent as in the highway task, but what seems to be happening is kind of the effect I would posit is being driven by those conversation partners really kind of stopping talking as the driver is approaching the intersection, kind of giving them time when they can see what's, even if they can see just the front screen, giving them time to kind of make a decision about turning and then resuming those conversations. So we have some less evidence there that we're getting changes, but we do still see some evidence that the video phone is changing the way these pairs are conversing. Okay, so I'm just going to summarize quickly. How are we doing on time?
Good.
Okay. Summarize quickly and then talk about a few kind of future directions and some conclusions with this. So we do see overall with those two studies some evidence of a benefit of videophone conversations. And importantly here, and I probably didn't emphasize it enough, this is relative to cell phone conversations. So it's not the case that we're alleviating all of the distraction relating from conversing, but we are mitigating some of the distraction related to cell phones. And we've extended this both to younger and older folks. Older drivers seem to be able to benefit to relatively the same extent as younger drivers. And we also see some evidence that this is even the case in intersections. And again, to show this picture and kind of come back to the point, really this might be enough to kind of change the way pairs are talking. And this is really, we think, again, driven by changes in situational awareness, both in terms of how much these pairs are talking about traffic, so kind of grounding behavior, both referencing things in the driving scene, as well as kind of generally reducing their complexity when they notice that the driver is doing something important. I don't have alerting behavior in here. I know I had it on one of the first slides. We don't see very much evidence for alerting, probably especially in our highway tasks because the events are happening so quickly. That's not to say that alerting isn't important or couldn't be important with this video phone interface. I think it's mostly the lack of alerting here is driven more by the nature of our experimental scenario. Okay, I mentioned earlier that we coded where that conversation partner was looking. So here we have kind of where the passenger was allocating their attention. So this is the percentage of total time where the passenger was looking out at the driving scene versus looking over at the driver. This effect makes sense. If you think about what you're doing as a passenger, you're probably not sitting there staring at the driver, which might be distracting in itself. But what's interesting is that if we look at where our video phone partner was looking, they're splitting their time pretty equivalently between the driving scene and the driver, so between those two screens. So we see kind of a different strategy here. And this, I think, poses a number of interesting questions going forward. One being whether it's useful just to show people the driving scene. So I think that's an important question. I could also make the case that there's very important information being conveyed by the driver's face in terms of things like engagement. So that's kind of one of the very reasonable extensions here, I think. To kind of come to this kind of overarching question of whether we should use video phones or whether we should replace all of our cell phones with video phones, at least while we're talking to drivers. I think, again, this is pretty early evidence, the first two studies on this effect, but we do see benefits of the video phone. And importantly, there's no additional costs in any of these instances relative to the cell phone. So we're not getting additional cost to having that extra visual information conveyed to the conversation partner. Again, this is still less safe than driving undistracted in almost all of the effects that we looked at. So probably, if we were to imagine an ideal situation where we drive without this information, people are going to talk on cell phones, maybe it's useful to have these things. There's a number of important issues, I think, before kind of coming to a final conclusion on this, obviously. There's things that we don't include here which are almost certainly going to exist out in the real world, things like lag in the video feed that people are seeing, as well as changes in some of the visual conditions which might make it hard for the video phone partner to see what's happening. I think screen size is a really big issue. So there's a big difference in what you can show on a screen like this compared to on a screen like this. And I think that's one of the questions we want to address going forward here. And again, kind of come back to this picture. I think we also need to understand what happens with this video phone when our conversation partner is acting like this, as opposed to kind of the ideal conversation partner who's helping alert the driver to things they should be noticing. And finally, I think kind of one interesting possible extension of this that we don't really address with these results, but I think is very applicable is this idea of kind of the shared responsibility in driver distraction. So this is a public awareness campaign in India, which is trying to kind of lay some of the blame on conversation partners for cell phone distraction. So if you can't see it, it says don't talk while she drives. The idea here is that if you make this conversation partner kind of feel responsible for creating driver distraction and impairing driving performance, maybe what this conversation partner will do is just hang up the phone if they know the driver's on the phone. And this video phone, I think, could be kind of a useful way to kind of convey that information in a very direct way. So I'll stop there. Again, I'd be happy to answer any questions. That's a lot of data presenting very quickly. But I'd like to thank the group at Illinois. This is the one I have in here, I guess. Both my advisor and collaborators, and really especially the undergraduates and RAs who ran these studies. As I mentioned, it was not the most fun research study to run with older folks getting sick in the simulator. So thank you for listening. I'd be happy to answer any questions. Yes?
I have a question. My name is Amani Farag. I'm from the College of Nursing, and I'm interested. I'm still stepping into this area about the fatigue. All your participants were rested. So one of the major issue in the nursing and in the medical field in general is the fatigue. Like after 12-hour shift, they have to drive to go home, or if they're called in the middle of the night for a case or something like that.
Sure.
Have you examined this with these people? Because like being sleepy, it affects your situation awareness to start with.
Absolutely. We haven't. It's a huge issue in driving that.
We have.
Yeah.
But
Okay.
you haven't to start.
Not with this kind of paradigm, no.
Okay.
I will say there's some evidence. I mean, we've done work at the simulator here at Iowa
Yeah.
with fatigue drivers, and we actually have another study coming up pretty soon.
I like to hear.
Yeah, we can talk afterwards. But there's actually some evidence from naturalistic data with heavy truck drivers where they actually put cameras in real people's own vehicles for like a year, is that there's actually a protective effect of talking on the phone at 2 in the morning because it keeps you awake.
Yeah.
Mm-hmm.
So people are less likely to get in a crash if they're on the phone late at night.
And then, yeah, there's some experimental evidence too, some stuff from Paul Ashley at Kansas, which kind of supports those
So
effects.
I guess they all need to be like calling each other on the way.
Yeah, I guess, or something like this, or maybe like a student going to a test. Like I remember me driving to go to a special test or something, so I'm more cluttered about this task other than the
Yeah.
driving. So.
And there's some kind of basic psychology, some pretty recent stuff from Illinois actually, which suggests that if you kind of give people kind of intermittent breaks when they're doing a very fatiguing task, like monitoring driving when they're tired at night, when there's not a lot going on, and they just kind of have to keep paying attention, that if you give them little breaks every once in a while, which conversations might
Yeah,
be,
this is
that might be a way to kind of enhance vigilance. Yeah, sorry. I don't know who was first.
Okay. So I was wondering if you guys thought about doing the same study, but having both of your participants driving, or one walking with a cell phone, because this does assume that the person who's your partner, who's talking to you, is just not distracted, not doing anything.
Absolutely.
So I could imagine that if you had 2 video phones mounted on a car, and this happens, people are talking to each other while they're both driving,
Yep.
that you could actually perform worse with a video phone than with a cell phone.
Yep, that would be my prediction. We haven't done anything.
Visual
I think
workload.
that's,
Yeah, because
Yeah.
you have more visual distraction.
yep. We kind of joked about the idea, or kind of talked about it a little bit with kind of connecting our simulator and our cave. We have a crossing simulator similar to what you guys have here, and kind of having people converse while they did both experiments. We haven't done anything like that yet, but that would be my prediction, is that if you give the conversation partner too much to do, that they're either not going to use that information or try to use that information when they shouldn't.
Yeah. I mean, could you do that with like the mini phones?
Yeah, we have done, I think, one study where we've hooked up multiple simulators and they're in a shared environment. I mean, I guess they wouldn't even really have to be a shared environment.
They don't have to be shared, they
Yeah.
just both have to be driving.
Yeah. We definitely do that.
So John, I understood that the driver wasn't provided with any additional conversation information. It was all audio. It was just verbal conversation for the driver. They weren't ever provided additional.
Exactly.
Like, they couldn't see the conversation partners.
No, and that was deliberate.
Yeah, I just wanted to make sure.
Yeah, I think if we did show them things, as Jody was suggesting, there would be probably some costs associated with that.
So did you look at, you looked at speech and gaze of the passenger, or did you look at speech and gaze of the driver and how it was influenced by the?
We did. It changes in much the same way as, not to the same extent necessarily as we don't get as big of effects between conditions, but we still see kind of more referencing of traffic, less talking, more pausing, those sorts of things. So it's not just the conversation partner. We think the conversation partner is the one who's driving that effect, but there's changes in both conversations. Yeah.
And have you ever done just pure listening to see what the effects on the, I mean, I'm thinking of listening to a radio, but
we've done it
books on tape.
Yeah, those studies have been done. We've done it in our cave, in our street crossing experiments. There tends not to be much of an effect, actually a little bit of a protective effect when people are listening to like an iPod and crossing the street, with some caveats there. But much less cost. It really gets to kind of how engaged the pairs have to be in the actual conversation, kind of how much of that attention drivers have to devote to that task.
I mean, I had done some work when I was at Texas A&M looking at teen drivers in this same situation without the video phone, either with a passenger or with a remote partner. And what we found is due to their inexperience, the teen drivers look at their passenger more. You know, they take their eyes off the road because they haven't figured out as a novice driver that they really need to be looking at the road. So their eyes off road time was really high. And actually they did better, they drove better with a passenger, I think, they actually drove better on the cell phone because their eyes were on the road.
Yeah.
And that's some, the crash data bear that out. I mean, the teenagers, as you add the number of passengers, the crash rate, increases exponentially because they're just visually distracted.
Well, I thought that looking data, FaceTime for the passenger versus the video phone was really interesting. Mm-hmm. It's like the passengers know because they're sitting with the driver, they shouldn't look at the driver to distract them, or it's a different conversational dynamic because they're not looking at one another. It's a different.
Yeah, exactly. Yeah. I think those data kind of create one of the most interesting questions coming out of this. Yeah.
What was the configuration of the monitors for the front screen and the driver?
So they were just right next to each other, kind of. So you're saying what the video phone looked like?
Yeah.
They kind of looked like that. They were like 19-inch displays.
Okay. Do you think these close together make this result? I mean, because the driver scene is in the field of view of the actual scene. Do you think, for example, if you move this monitor to, for example, left side?
Yeah, I feel like you had them reversed because they were looking to their right to see the person, right?
Yeah, looking to our right to see the person.
In a car, you look to the left to see the person.
In the U.S.
These are Illinois.
That's a good point. I haven't thought about that. That's a good question. If you made it more effortful, required more effort for them to turn their head to actually look. So if you configured it just like a passenger would be, it's a good question.
Well, the same goes for the video angle too. But I guess if you were to implement that video technology, you would get a face front.
Yeah, that's one thing we've talked about looking at is if we could make it more, if we put the camera in the passenger seat, something like that. We kind of went for what we thought would be most realistic in terms of actually implementing this. But I think there's some good questions there.
Could you explain again why you didn't get the expected trend in results of the first part? I think a braking event or something.
So that's a really good question in terms of why we're not getting an effect with those brakes. What I think is happening is that, so one of the effects of conversing, which I mentioned briefly at the start, is kind of this constriction of gaze. So when people are talking on a cell phone, they tend to look straight ahead. And our eye tracking data are pretty noisy with this, as you probably know from working with simulators. But what I think is happening is that when people are distracted, they're just kind of focusing straight ahead. So we're not getting necessarily a benefit for things that are happening directly ahead, but what is happening is we're getting a benefit for those things that are happening out here. Does that make sense?
Yeah, but you found a benefit in intersection scenarios in the part 2. In the intersection, I think the things are going on in the peripheral area.
True.
So what's the difference?
I think there's differences in kind of the requirements of those tasks. I mean, intersections, people are actually turning their heads, looking around. That highway task doesn't require them to do that. So there's not much. We looked at kind of the breadth of how people stand at intersections and didn't see much of a change there based on the conversations. So I think it's kind of two different tasks, more than kind of the same effect.
Okay.
And I don't know, I'm not sold on that answer yet, but that's kind of our leading hypothesis.
Thank you.
Sure.
I'm not sure what the research question would be, but it would be really cool to put the passenger in an HMD where they could actually kind of be there in the passenger seat and look and see the environment around them, which would be doable.
That would be really neat.
They're Oculus.
Exactly.
You just want to buy an Oculus, right?
We have
one.
We're trying to figure out what to do with it.
Well, there you go. Well, that's a good segue into, our center does fund pilot grants, and the RFP is active right now, and the information's back there. They're due in a week. It's just a 2-page thing. Doesn't take much. I'll talk to you afterwards. I know there's a couple people in here that are going to apply, and it's really primarily to fund graduate students, so it can be graduate student initiated. You need to have a faculty or staff advisor working with you. So I'm going to cut it off, but I'm sure we can all stay and chat, and we can turn the video off. So take a cookie, take a tire pressure gauge, take a pen. Thank you for coming, and I think you must have all found out somehow, so whatever communication we're doing is working. So I'm happy to see such a mix of people.
Thank you.
Thanks, John.